In question 5a, the manager claims the average weekly loss of man-hour after implementation is not more than 20. We're going to examine his statement using the hypothesis testing. Following the standard procedure, we first formulate the null hypothesis, assume the population mean equal to 20. Then we formulate the alternative hypothesis. Since the sample mean is 27, we set the alternative hypothesis as population mean is larger than 20. According to the hypothesis, this is a one-tailed test with a significance level at 1%. The following step is to set the test statistics as well as the critical region. As the sample size is 30, we apply the z-test here. At one-tailed 1% significance level, the critical z-value is 2.33. If our calculated z-value is larger than 2.33, which falls in the shadow region, we then are able to reject the null hypothesis. And consequently, we input known figures to calculate the z-values, which is larger than critical z-value. Thus, we can reject the null hypothesis that the population mean is equal to 20. And eventually, we conclude that at 99% confidence level, the manager's claim is incorrect.
Hi, I'm Sarah. I'm going to talk about question 5b. In question 5b, we're given two sets of data, which are the concentration of suspended particles in Commercial District A and Commercial District B. And we are asked to test whether the mean concentration of suspended particles in District A is less than that in District B at 1% level of significance. We denote μA and μB as mean concentration of suspended particles in District A and B respectively, and SA and SB as the sample standard deviations of the two samples. And then formulate the null hypothesis, which is μA minus μB equal to 0, and the alternative hypothesis, which is μA minus μB less than 0. As stated in the question, the level of significance to be used is 0.01, and this question is a one-tailed test. Before we test our hypothesis, we first need to select the appropriate test statistic. By referring to the summary table on page 88 on our study guide, since in this question, both sample sizes are small with n less than 30, and both sigma are unknown, we apply the t-test here. And there are two formulas, and we choose the upper formula as stated on the screen. And to use this formula, we need to assume the populations to be approximate normal with equal variance. After choosing the appropriate test statistic, we then calculate the critical region. For this question, since the level of significance is 0.01, and for the V, it is N1 plus N2 minus 2, which is 13 plus 16 minus 2, which is 27. And by referring to the table of student T distribution, we can find the critical value as negative 2.473, and therefore the critical region is less than negative 2.473. After calculating the critical region, we can formulate the value of the test statistic. And for a question, N1 is 13, N2 is 16, μA is 72.9, μB is 81.7, SA, which is the sample standard deviation of District A, is 25.6, SB, the sample standard deviation of District B, is 28.3. And we can use the formula to calculate the t-value. And we can first calculate the SP using the left-hand side formula, and we can then substitute the answer into the formula on the right-hand side, and then we can have the t-value, which is negative 0.87. Since the t-value negative 0.87 is larger than negative 2.473, which is the critical value, therefore the t-value is not in the critical region. And we can have the decision that we do not reject the null hypothesis, which is mu A minus mu B equal to 0. And finally, we can draw the conclusion, which is the mean concentration of suspended particles in District A is not less than that in District B at 1% level of significance. That's the end of question 5B. Thank you.
So upcoming, I'm going to talk about question 1C. So question 1C is talking about QMB group is thinking about opening a new retail store in a particular district, and the group decides to do some research to make sure that the venture will be profitable. So family incomes has been a good indicator of the profitability in past, so therefore the group takes a random samples of the families in the district. So the table shows here is actually the monthly incomes of the sample. So the first thing we notice about is that the monthly income classes, they are not ending and starting at the same point. You can see this numbers and this number is different. So to deal with this problem, so we are going to make good use of the class boundaries. So the second thing is that we need to calculate the total numbers of the family. So in this random sample, the total numbers of families would be 140. So, okay. So in the part C of this questions, it tells us that if more than 40% of the families in this district has a monthly incomes above $25,000, the group will decide to open a new retail store. So test at a 5% of level of significance whether the group should open the new retail store in the district. So by understanding the questions, we can actually conclude that we are going to use a one-tailed test. It's because we are only having one critical region instead of two. So we are going to have a one critical region and accepted regions. So in the first step, we are going to formulate the hypothesis. So H naught would be P hat equals to 0.4 and H1 will be equals to P hat larger than 0.4. So since we are not having a real P, because this is only a random sample, so the real P will be estimated by P naught, and the alpha would be equals to 0.05, as because in the questions it states that the levels of significance will be 5%, so which is equals to 0.05. So next we are going to find out the proportions of the random samples, that how many families are having a monthly incomes of $25,000 or above. So since we just now we have mentioned about the monthly income class here is not end and start at the same point, so we are going to use the class boundaries. So the numbers here is actually the class boundaries, so we will minus the class boundary. Since $25,000, this number will lie in this we will lie in this class, so we are going to use this class boundaries and then minus by $25,000, and then we will divide it over the numbers will be over the whole range of the classes, which is this minus this. So the whole numbers will times 30 is because which is also the numbers of family in this class. So since we are finding out the numbers of families having more than $25,000, so we also need to add up the three numbers here, which is 18, 17, and 9. So, and then the whole numbers will be divided by the total numbers of the families. So which is 6 plus 22 plus 38 plus 30 and 80, 70, and 9, which is the total numbers of 140 families. So we will, by inputting the data, the H naught will be equals briefly to 0.42. So because we are actually having a sample size of larger than 30, since our samples is 140, so we can use a set distribution instead of a t distribution. So since the whole question is concerning about the proportion, so we can use this formula to help our calculation. So we will input the data one by one, since we have calculated the P naught, and then 0.4 will be the P, our critical region, and then we can get a numbers of the test statistic will be briefly equals to 0.52. So after we get the numbers of 0.52, by referring back to the distribution table, 0.52 is smaller than 1.64. So from the graph we can see that this is actually our critical region. So this is the acceptance region. So we can draw a conclusion that having a sufficient evidence to not reject H0 and so the company should not open a new retail store. So this is the end of question 1C.
Hello, my name is Fong Kai Leung from Group 5. Today I'm going to talk about question 4C of Mod 4. First, let's look at the question. In order to test whether a special training program is effective in increasing sales made by salesmen of a large printing company, the following data are collected concerning the weekly sales in $1,000 of 10 randomly selected salesmen, both before and after attending the training program. Now we have mu A and mu B as the mean weekly sales before and after the training program respectively. For the null hypothesis, mu A minus mu B is equal to 0. For the alternative hypothesis, mu A minus mu B is smaller than 0, and alpha is equal to 0.025. As we assume that the population is unknown, and the sample size is smaller than 30, we should apply t-test here. Since V is equal to the sample size minus 1, so it's equal to 9. So the critical t value is equal to negative 2.26. Next, we found that the mean of differences between these two samples is equal to negative 0.64. Also, the sample standard deviation of differences between two samples is about equal to 1.86. So we can find the test statistics is equal to negative 1.09. As the test statistics is a value in critical region, we should not reject null hypothesis. To make a conclusion, there is no evidence to suggest that the program is effective at 2.5% level of significance.
And I'm gonna explain on mock test 4, question 5, part A. From the question, we know that the mean daily expenses per tourist in Hong Kong is at least Hong Kong dollar 2,000. To test this claim, a random sample of 100 tourists is interviewed. So it means the N in this question is 100. It asks us would you agree with the claim if the sample shows the mean daily expenses of Hong Kong dollar 1,850 with a standard deviation of Hong Kong dollar 500, and it tells us to use 1% level of significance. To calculate this question, the first step we need to do is to formulate the new hypothesis, which is H0 mu equals to 2000, and step 2 is to formulate the alternative hypothesis, which is H1 written down as mu is less than 2000. So to substitute to the question, we know that alpha equals to 0.01, and it is a one-tailed test. So next step, we can select the appropriate test statistic and establish the critical region. Because the sample size is large, n equals to 100 is larger than 30, so we apply that test here. Since alpha equals to 0.01, we can check the number from the table and to see that critical Z value equals to negative 2.33, and we can also draw the diagram like this. And next step, we can use the formula and to plug all the numbers in to calculate that Z is equals to negative 3. Our decision should be reject H0 if the statistic has a value in critical region, otherwise accept H0. From the calculation, we know that Z equals to negative 3 is smaller than negative 2.33, thus we reject the new hypothesis, H0, which is mu equals to 2000. And then we can draw the conclusion according to the decision made in step 6. There is sufficient evidence to suggest that the mean daily expenses per tourist in Hong Kong is less than HKD 2000 at a 99% confidence level.